The purpose of this course is to show some of the differences between the old and new beryllium standards, and offer a brief overview of the final ruling of the new beryllium standard. And the primary focus of this course are changes for the general industry standard. The element beryllium is a gray metal that is stronger than steel and lighter than aluminum. Its physical properties of great strength to weight, high melting point, excellent thermal stability and conductivity, reflectivity, and transparency to X-rays makes it an essential material in the aerospace, telecommunications, information technology, defense, medical, and nuclear industries. Beryllium is classified as a strategic and critical material by the U.S. Department of Defense. In 2014, the U.S. produced 270 metric tons of beryllium domestically and imported 68 metric tons. Beryllium is used industrially in three forms: as a pure metal, as beryllium oxide, and most commonly as an alloy with copper, aluminum, magnesium, or nickel. Workers in industries where beryllium is present may be exposed to beryllium by inhaling or contacting beryllium in the air or on surfaces. Inhaling or contacting beryllium can cause an immune response that results in an individual becoming sensitized to beryllium. Individuals with beryllium sensitization are at risk for developing a debilitating disease of the lungs called chronic beryllium disease, or CBD, if they inhale airborne beryllium after becoming sensitized. Beryllium-exposed workers may also develop other adverse health effects such as acute beryllium disease and possibly lung cancer. The health dangers of beryllium exposure have been known for decades. OSHA's old permissible exposure limit, or PEL, for beryllium was both outdated and ineffective for its preventing disease. Over the decades, a consensus has developed around the science supporting the need for greater protection for workers. Many employers, including the U.S. Department of Energy, are already implementing the necessary measures to protect its workers from beryllium exposure. The technology for most employers to meet the new standard is widely available and feasible. For more information on beryllium health hazards can be found in the preamble of the beryllium final rule. End products containing beryllium and beryllium compounds are used in many industries, including the aerospace industry for aircraft braking systems, engines, satellites, and space telescopes, the automotive industry for anti-lock brake systems and ignitions, ceramic manufacturing for rocket covers and semiconductor chips, in the defense industry for components for nuclear weapons, missile parts, guidance systems, and optical systems, in dental labs for alloys and crowns, bridges and dental plates, in electronics for x-rays, computer parts, telecommunication parts, and automotive parts, in the energy sector for microwave devices and relays, medicine for laser devices and electromedical devices and x-ray windows, nuclear energy for heat shields and reactors. It can also be found in sporting goods with golf clubs and bicycles, and finally in the telecommunications industry for optical systems and wireless base stations. Prior to 2017, OSHA had a permissible exposure limit for beryllium set to 2 micrograms of beryllium per cubic meter of air, and a ceiling of 5 micrograms of beryllium per cubic meter of air. Additionally, beryllium was addressed under 1910.252, that is the welding, cutting, and brazing standard, which stated that welding and cutting of beryllium-containing compounds shall be done either under local exhaust ventilation or the worker wearing an inline respirator. In 2017, OSHA issued its final rule for beryllium, which requires employers in general industry, construction, and shipyards to implement protective measures for workers who are exposed to beryllium. The new beryllium standards are 1910.1024 for general industry, 1926.1124 for construction, and 1915.1024 for shipyards. The effective date for the final ruling on beryllium was March 10, 2017. This is found under the Code of Federal Regulations 29 CFR 1910.1024. As part of the final ruling, OSHA reduced the permissible exposure limit of beryllium from 2 micrograms to 0.2 micrograms per cubic meter of air over an 8-hour time-weighted average, and established a short-term exposure limit, or STEL, of 2 micrograms per cubic meter of air over a 15-minute sampling period. In addition to these changes in exposure limits, employers must also use engineering and work practice controls to prevent excessive beryllium from becoming airborne where workers can breathe it in. Employers must limit access to high exposure areas, provide respiratory protection when necessary, and provide personal protective clothing when high exposures or dermal contact is possible. Employers must also assess exposures, develop and implement written exposure control plans, and provide workers with training specific to beryllium. And employers must offer medical evaluations to certain exposed workers. If a specified beryllium-related health effect is identified, they must offer additional workplace accommodations to the worker to reduce beryllium exposures, as well as other key points in the standard. For more information on the standard, please see our website at kysafe.ky.gov and click on the Beryllium webinar. And additional information on OSHA's beryllium rule can be found at osha.gov/beryllium. Thank you for attending this presentation today.